Okay, so if you're following along, this is the repository that where everything's stored. So github.com /codehouse/unity sticky notes, well, sticky dash notes. And that's in the comments below. So if you look in the comments below, and you see we have a README here, and it's got you know, these kind of things in here. I'm actually going to change, although, yeah, I'm probably going to take out this here, because this has got the sort of video notes. I'm going to change that to a to-do. So that being said, this is the to-do that I'm talking about. So in this one here, I have video 2. So this is the ones that we did for video 1, and this is the sort of topics that I wanted to do in video 2. I got a note from Micaiah Stevens, and I hope I'm pronouncing your name right, who suggested that when I was doing the sticky note UI, that I could have used text mesh, and you're perfectly right. I could have used text mesh. And I don't really know why I didn't think of it, because I kind of wanted a sticky note feel to it. But yeah, you're absolutely right. And what we're going to do is, as part of this video, oh, Adobe's ready to update. You can't see that, but I can. As part of this video, we're going to make this a little bit more extensible. So part of it is we're going to do a bit more extensible, because the trivial part is actually serializing out the sticky notes. We just have to decide a few things. So are we going to read and write from disk per scene, or like, are we going to make it all separate files per scene? Or are we going to make it one huge big file? I should actually say that would be a file, because we have the database down here for video 3, which is going to be the last one. So this is what we're going to do for this video here. And then we have a few things to decide, and we'll do that when we get to this point. But you know, when's the best time to save those changes? What, you know, is it when a note's made, or is it, you know, when you update it, or is it, or should it be like an autosave? And we can do all these kind of things. In fact, autosave is relatively painless to do in Unity because we have the coroutine functionality, so it's perfect. And then finally, where should we write the data to? Should we do it per user? Or should we do it per project? Like, where can we save that database? So that's kind of what we're looking at just now. But let's focus on this part here, which is making the system a little bit more extensible. So we go to just do a sort of review of what we actually achieve. So we have our chap Ethan running around the world, and then we go into the debug menu, and then we click on add note, and then we can specify whatever the text is. So this is a bug, and then we click on save, and then we can come back out, and you can see that this is a bug is written inside there, and we can wander around the world, and we can sort of see these things from afar. So if we run over to here and then, you know, turn around and face this direction, you'll see that the camera spins around eventually, and you can see that we have our bug report over here, and we can see, oh, there's a bug over here, so we can go over and check it out. Now, inside a bug, we have our sticky note here, and then inside there we have a sphere, and then we have this, where are we? We have a sticky note world bug item, which is a script, and this sticky note item script has this function in here, which is called set bug text. Now, really what we want to do is we want to make that as extensible as possible. So instead of having bug text, because we might want to have, you know, other things in there. So instead of doing that, what we're going to do is we're going to add to this functionality, or to the functionality that allows us to pass in an object. Now that object that we pass in is going to be our sticky note. So we have our sticky note here. I'm just going to move this over here. So we have our sticky note over here. There's a couple of other things I want to add. I want to say public date time. I'm going to call that timestamp. And What else do we want? Do we want anything else in there? I don't think we want anything else in there. But what we do want though is we want this to be an interface, because we want to be able to manipulate this somehow, or maybe we want to change it. So I'm going to add an interface, and I'll explain for those of you who don't know what an interface is, I'll explain in just a sec. But the easiest way to define an interface is to create a new class. So we could click on new item, and we don't get much of a choice here, but I'm going to call it iStickyNote. And we click on add, and we get rid of mono behavior there, and we get rid of that there. Now, most people know that when you have a class, you have your classes. My cursor disappearing. When you have a class here, then you're defining a blob that contains many members. And those members can be fields, they can be properties, they can be functions or methods. In other words, the attributes are the things that describe the object, the class, and then we have the methods, and those describe what you can do with the class. Now, that is set in stone. You're saying that this, when you call this, you call the method foo on an object, it does a particular thing. Now, an interface, all that does is it sets up a contract between the person who is calling that object and the person who created the object that said they will provide these functions. You don't need to know how they're implemented. In fact, you should always, quote unquote, code to the interface. This is what they mean is by code to the interface. So instead of using the word class, we have interface. Now, we can't create an interface directly. Okay, you just can't do it. You can only implement an interface. So what I'm going to do just for now is I'm going to grab all these values here, and I'm going to paste them in here. And I'm going to go through, hopefully it'll start giving me exceptions here. So the first one is the DateTime. So quick action is using system, because obviously we need to have our system. We don't need collections. You'll see that all of these have red squiggly lines on them, and that's because everything in an interface is public. And the reason why everything in an interface is public is because your class has to implement that interface. It's the thing that says, I have this functionality. So we can get rid of all these public variables. Public accessors, I should say. And the easiest way to do it is if you hold down the Alt key. I'm going to hold down the Alt key, and then I'm going to drag out a rectangle, and that creates a rectangle of highlighted things, and I'm going to hit delete. There you go. And then it all goes away. So now what we're saying is I have some class that has to implement sticky note, or sorry, this interface here. If I put this in a class, that class has to have a public property called scene, and it has to return a string, and it has to have a getter and a setter. And the same thing for bug text, position, and timestamp. And so I'm going to say iStickyNote, and then I'm not going to get any bugs there. That just says either, it depends on whether you're using a class or an interface here, but this, in this case, this is implements this interface. So hopefully that's a little bit clear. It should hopefully be clearer as we go on here. So we have our sticky note controller, which I think is down here. So we have our new sticky note. So notes, current note is this new sticky note. So instead of having sticky note here, I'm going to replace all of these with iStickyNote. And you'll see that we should get a couple of errors. And I think that should be us. And we're not making many changes in here. We're just making it an interface. And then this in here we can actually take out, and we can make a factory, but I'm not going to bother doing that. This is good enough for a factory just now. But I do want to add our timestamp equals DateTime time dot no. Let's use UTC now. Or do we want to use UTC now? Let's just use now. Oh yeah, don't put a semicolon there, Sloan. Okay, and then that satisfies that. Now, the next thing I want to do is we have our sticky note world bug item. Now, our sticky note world bug item, we want to be able to extend that now from McKay's suggestion earlier on. We want to be able to set a text mesh or anything, any prefab that we want to set up, and we'll do that in just a sec. And we want to be able to set that value. We want to be able to set the text inside the bug on that value. So what I'm going to do is I'm going to say I sticky note bug item. So I'm going to say it is a sticky note bug item. Now you notice that I've got a comma here because what you can do is you can only extend from, in C#, you can only extend from one class. So I can say that this bug item is a model behavior, but if I want to add more functionality to the class, or advertise that I'm adding more functionality to the class, I can implement many interfaces. And the way we do that is we put in a comma and then put in our interfaces after that. Always use your base class first, then comma, and then interfaces after that. Because it says this class is derived from this class. Oh, by the way, it also implements this and this and this and this and so on. You notice that we have a red squiggly line there, and the reason why is because we need to have, I'm going to create another class in here, and it is going to be called the name of that interface. So that's going to be I, and I've called it that again, sticky note bug item. I'll fix these spelling mistakes in just a second. So this is an interface, and there we go. So I sticky note bug item, I sticky note bug item, and this is going to be an I sticky note bug item. And you'll see that it says it's okay, there's no mistakes. But what I'm going to do is I'm going to say add void, and then it's going to be what do we want to call it, set, or do we want to call it yeah, let's just call it set, and then we'll call it I sticky note. And that is our interface. That's the only thing that we're going to implement in our interface is this set function here, which is going to take a sticky note as a parameter. And you'll see that now we have our red squiggly line here, and we can just go to the little light bulb, click on implement interface, and you'll see that it immediately puts in an interface here, which takes in sticky note and throws this not implemented exception. So what we're going to do is, instead of having this text here, I'm going to say text.text equals sticky note dot, and then it's bug text. Okay, so again, we don't know, sticky note could be anything. You could extend sticky note, you could have additional functionality in there that may be good for your purposes, but I mean, I don't know, you can have additional functionality in there for whatever reason, but it has to implement this. Your class has to implement this interface, and this interface must have a scene, a bug text string, and then a position vector, and then a timestamp. And then I'm going to get rid of this here, which now means we are in trouble, because when I go back to here, you'll see that we have an error that says sticky note world bug item does not contain a definition for set bug text and no extension method. It could be found. Are you missing an assembly reference? Well, no, we're not, but we are missing this interface, because what we're going to do in the controller is, instead of having a sticky note world bug item, we are going to have sticky note bug item. We're going to have an interface, okay? And we're going to have to do a little bit of sort of trickiness to get this to work, but that's okay. And so our bug note, our set current note, we're going to have to change some things in here as well. So this is going to be sticky note, and that's going to be set, and that's going to be our bug text. In fact, that's just going to be bug, because our set is our interface method, and then our sticky note is going to be this. That's it. And what else is there? And then this one here. That's it. And that's all we need to change there. And then everything else will just work. Now, the problem we have is we have no way to get this sticky note bug item. And the reason why we have no way to get this sticky note bug item is actually we need to also pass in this one here as well. And current note equals bug item. Current note is also going to have to be this one as well. Okay. And that's going to change a couple of things over here. Current note dot transform dot position. Okay. We're going to have to figure that one out. Oh no, that's okay. So we just don't need to, instead of using that, we can say game object. Actually, it would be position. So there you go. So that saves us doing that. And then down here we have DestroyMe. Okay, so DestroyMe, we need to have a method in there as well. So if we go back to here, we also need to have a void DestroyMe. So we'll have a void DestroyMe here. And then that gets rid of all the red squiggly lines. Okay, so that's us. We've tidied everything up. We've made it a little bit more extensible. So now we have an interface. So it's any class that we want that takes in this sticky note bug item. And then we have our sticky note here, which again could be anything. And then we have our current sticky note, which is also a sticky note bug item. Okay. So now we need to figure out how to get that bug item. And the way we do that is we use this get component in children sticky note world note bug item. But if you're extending this, if you're writing your own class, you're not going to have a sticky note world bug item. You're going to have, you know, some other class, and we'll show that in just a sec when we do our text mesh one. So it's kind of important to be able to get it by interface. So I'm going to create a class here, a static class in fact, and it's going to be called game object extension methods. Actually just extensions. I'm going to make it a static class. And I say public, what do I need to call it? Get component in children. So this is going to be, what does get component return? It returns the type that it is. So it's going to be public t get by interface. Actually, it can be get in children as well. Get by interface in children, and then it's going to take in this game object, and there you go. Okay, so this is going to be slightly costly, so you really want to do this at the very start. Oh, that's also going to be a static as well. You want to do this in your, you don't want to do this as a sort of every frame. This would be bad, but for a one-off thing and for debug functionality, it's not too bad. If you want to use this in game code, probably not recommend it. But if you did want to do that, then I would say that you would do that inside the awake method. That's probably the best place, or at least before you do any like scene processing. All right, so what we're going to do is we're going to go through all the objects inside the parent object and then all the child objects and find the first interface that this matches. And the way we're going to do that is we're going to say return get by interface in children t game object. And then, do we want to do that there? Actually, no, we don't need to do that. We can do game object dot get components. Do I need to specify a type? And then it's going to be mono behavior because it's a script. Get components mono behavior dot for to array. Can I do this as a link? Yeah, I think I can. Dot for select. No, let's just do the bog standard way. I thought I'd try and be clever there, but let's not be clever, let's just be accurate. So we're going to say for each var component in mono behavior if c.getType. So we're going to use what's called reflection here, and we're going to get the type of the component. Now the component, the type gives us more information than you really need to know, but what it does allow us is it allows us to get to the what interfaces it implements. So we can say get type dot get interfaces, but we can specify just one interface, and then we want to do type of t dot name is not equal to null. Get interface name type does not contain interface or name. Yes, it does. Name. There you go. So if it's not equal to null, return C. Okay. So we're going to go through. Oh yeah, we need to cast it as T. Cast is redundant. Can I convert mono behavior to T? Cast is redundant. Can I do where T mono behavior? Okay, I don't know why that. Yeah, all right. Let me think. Why would that balk at it? Maybe it was getting confused. Somebody's dropped something. Maybe it's getting confused as to why it doesn't know what T is, so it's getting confused that way. I don't know. I'd have to think about that. But really what we want to do is we want to go through, let me just explain what we're doing here. We want to go through each of the components inside that game object, and we want to find out if that component is of this particular type. And if it is, we want to return that component. Otherwise, I want to say for each var, actually I need to do for int I equals 0, I less than GameObject.getTransform.get child, is it child count now? I++, and then it's going to be var child GameObject equals GameObject.transform.getChild I if chgo equals null, continue, otherwise return GetByInterfaceChildren t chgo. What a palaver, chgo.GameObject, because chgo, the child, is actually the transform, so we need to actually check to see if it's equal to null, or chgo.GameObject equals null. All right, okay. And while we're here, what I'm going to do is I'm going to cut this out here and say var component equals get by interface t game object if component not equal to null, return component. And then I'm going to have another method here called public static t get by interface this game object. All right, return null. Then I'm going to have the same clause up here. And the reason why is because I want to be able to do this on a single object as well, and well, let's not have duplicates. So we have our get by interface. So it's get component by interface. So I'm going to say get component by interface. And then this is get component by interface in child objects, in children. All right, so we call this get by interface. If it's not equal to null, then we return that component. Otherwise, what we want to do is we want to go through all the child objects and then call this again. So we then check to see that game object. If that game object contains a component, then we go back through that. Otherwise, we cycle down through the components. So it's going to be slow. If you have quite a deep hierarchy, it could be slow. So just to let you know. So what does all this mean? Well, it means that we have our get by interface in children method. So now when we go back to our sticky controller, instead of using get component in children to find this sticky note world bug item, we can do get by interface in children. And you'll see that we have our value there, and then this isn't going to work. So we're going to say it's instead of sticky note bug item, we're going to use this interface here. I'm going to pass that in there, and that's not going to work. It's not going to like it because this where is not going to work. So oh wait, hang a sec, just need to do default t, that's why. Return default t, and then we do return default t. And then it doesn't like this cast here. Cast is redundant. Cannot explicitly convert. So this is the issue. So this one's okay, but the sort of main one that we want, this one here, it has a bit of an issue to it. So why is it not liking it? Well, it's not liking it because this T here, it doesn't know what to make. Cannot convert from C to T. So get component, let's call it component. Haha. It doesn't like that. Is there another way to just do get components? I just want that, get components. Type of behavior. No, still doesn't like it. Can I do, oh wait, I think I can do as T. No. Here. Okay. Yeah, and now that's not going to like it because that's the type T must be a reference type. Okay, so that's where T class. Right there. Okay, it's a little bit hacky. Not exactly how I wanted it to go down, but that should fix this one over here, which it has. So it kind of sucks the fact we've got to do that, but whatever. Okay, so let me just try and sort of get my head around the explanation in this one. All right. So I've had to say that T is a class type. So what that means is that by default, T can be anything. It could be an integer, it could be a struct, it could be whatever it is. So what I'm saying is T is some kind of a class. Now, the reason why I did this down here, if I change that to TC, it probably will fail again. And the reason is because it doesn't know a route that can convert between my T, my whatever the type is, and whatever the class is. And it's quite right because C, although it implements that interface, is not actually that class. But I should be able to cast to it, which is what it's allowing me to do. So I can, I should be able to do the dynamic cast to it using the as operator, which says take this object and then try and cast it as this type here, which then says if that fails, return null. So if it fails, it returns null, and all hell breaks loose. But everything should be hunky-dory now. So when we go back to here, after all that, 36 minutes in, nothing's changed, hopefully. So if I go back over to here, and then I create my new note, click on add new note, and then I enter my text, blarg, and then click on save, and you see that nothing has changed. Okay, so we've written all that code, we're 36 minutes into the video, and nothing's changed. However, we have abstracted out the need for that particular class. So now what I can do is I can go to, let me go to the asset store because I don't have this installed, and I'm going to download text mesh, which I've never used ever professionally or otherwise. And where do I want to go here? Alright, made that short and sweet for you guys. So right now here I've got our there's a user guide, all that kind of stuff, but I'm going to go ahead and just create a blank empty object, and I'm going to put it at 0, 0, 0, and then I'm going to add a component. No, I'm not. I'm going to add another blank empty object. So I'm going to call this one text mesh bug reporter thing. And then inside the game object here, I'm actually going to put text mesh, and then I'm going to add a component text mesh, I'm going to guess. Text mesh. Okay, text, and then the text is dummy text. Whoa, okay. So that is oh, okay, that's that there. That's fine. So that is the dummy text, and what can we do with this? I don't know what we can do with this. Am I even using the right thing? Who knows? Let's make it bold, and do we have another font? Bangers. Yeah, let's change it to bangers. And inside the game, it looks like that, and it looks okay. All right, that's good enough. Whatever the text is, okay. So we'll change that to text. And what I'll do is I will create another sticky note. So this is just I'm just going to create it inside scripts here, and I'll call this text mesh sticky note bug item. So I'll call it sticky note bug item. Doesn't really matter. Reload solution. And get rid of all of that, and then I will extend it into sticky note bug item, and I'll implement the interface. What's this? What is the sticky note bug item? DestroyMe. Okay, so let's do that. DestroyMe. So transform parent dot whatever that is, and then we need our void awake. Text mesh equals get component text mesh. Okay, and then inside set, I'm going to say text mesh dot text equals sticky note dot bug text. Okay. So fairly basic class. We've got our text mesh here. We grab the component when we awake. We've got our destroy, and we have our set method here. So this class, we've just created this class today, and inside this game object here, I'm going to add text mesh sticky note bug item, and then I'm going to add this as a prefab. So this is just going to be, what we call this, test prefabs. And I will drag that into test prefabs. And I'll remove that from the scene there. And then inside our sticky note UI, we have our bug report prefab. So I'm going to drag and drop this bug report prefab in here. And now when we run, we create our new bug, boom, and it creates this new value there. And then we can do this is the bug, and then click on save, and it changes to that there. And so when we, I think it displays it on top of everything. That's weird. Okay, so that's the text mesh. Anyway, that's the sort of point of the extensibility, is that is weird, the fact it just always writes on top of that. That is, I'm going to put that back to where we were. So that's the extensible part of it. Where's our prefabs? Prefabs, there we go. So I'll drag and drop our sticky note into there. Okay, so that's how you can extend the sort of visual part of the bug, and you can have different ones as well. We can extend this. We'll maybe spend some time, and maybe there'll be like a fourth video or you could choose the different ones depending on different situations, but that's the kind of idea behind it. Okay, so going back to this one here, this is all the part that we just did there. So we get component by interface, interface for node selection, interface for serialization. So we're going to do exactly the same thing for serialization because we want to have a separate serializer. We don't want to rely on we want to be able to pick and choose where we save the data to, because it could be that we have a communication where we send it to our phone, or we send it to a server, or we write it out to disk. So we want to come up with an interface for that, and we want to be able to just swap that out. So if we have our sticky note controller here, all we want to do is we want to drag and drop something else in there when we feel like changing it up and writing things out to a different location. So that's the idea. Okay. So what was the choices we had here? So we've done this bit here, serializing the sticky notes, read write per disk or one big file, saving changes. When's the best time a note is made? I think so. I think when a note is made, we'll do the save. Where should the data be written? Per user, per project, that kind of thing. There's also another issue as well, because inside our sticky note controller, this here is going to be this canonical comment below if you think it's canonical, and comment below if you think it's canonical. The last one doesn't sound right when I say it out loud. Canonical. Anyway, this is the important one. This is the one that's going to be in memory. This is the one that's going to change. And when we serialize things out, we're going to have to decide whether we want to save, how we're going to save that format out. Okay. I guess we just have to delve right into it. So I'm going to create another new item, and I'm going to call this sticky note serializer. Sticky note serializer. And the sticky note serializer is going to take in a save, and it's going to take in iDictionary, and the iDictionary is going to be these two guys here, notes, and then it's going to have an iDictionary, sticky note bug item, sticky note. Actually, it's just going to have list sticky note load. And that is an interface. Okay, so those are our two methods that we have to implement for any serialization. We have our save and we have our load. That's it. That's all we really need, because the database is going to handle, or wherever we decide we're going to save these things to, is going to handle those saves. And maybe we want to maybe like single items, but for now the bulk uploader is fine. So I'm going to create another class, and this one is going to be a mono behavior, and we're going to call this local disk serialization, or sticky notes local disk serializer. And this is going to be a mono behavior, but it's also going to implement our sticky note serializer, which you'll see that it doesn't actually implement just now, but we can do that. Quick actions, implement interface, and then we have our load and our save. So now what we have to do is we have to decide, I think we're just going to do it as a big file. So big file. And when's the best time when a note is made? Sure. That sounds sure. Sure. Where should the note be written? Per user, per project. Let's make it per project. I think that's all we need to do. I mean, these are decisions that we can change. It doesn't really matter as far as we're concerned. Actually, I don't know why I did that. As far as we're concerned, for this first bit of functionality, we just want to be able to save and load things from disk. That's a sort of main thing, and all of that's going to be handled by our controller. So I'm going to try and find where the controller is. The sticky note controller. So when we boot up the sticky note controller, we're going to have to go through this here, which means we're probably going to have to extract some of this information. So, all right. So we have our model and we have our sticky note there. So I want to do add. What is the model? Sticky note. Okay. So then inside serialization here, we also want another folder called, inside sticky notes, we also want a folder called serialization. Because, actually we don't need, we don't need that. We do not need that. What we need is, we need an IEnumerable sticky note. That's all we need, is an IEnumerable sticky note. In fact, all we need there is an IEnumerable sticky note as well. So that's all we need. So we're going to have to change our interface here to this accordingly. Okay, so all we need is an IEnumerable. That's all we need. Because we have the position information, we just need to be able to write that out any place. So our save is going to be get a serialization, our serialization structure, and then we have all the items that are inside that, and then we write that out to a string, and then we write that out to disk. So we're going to do add and then new item, and then we're going to call this sticky note save model data. I'll just call it save, or sticky notes data. Yeah, let's call it sticky notes data. And I'll leave it as a class, and then we'll have a public sticky, actually let's call it iSticky note, sticky note. System. I think we can get away with this. I think. I'm trying to remember if so I'm used to using Newtonsoft's JSON serializer, which is awesome. But I'm not sure if Unity allows us to do this, so it could be a short trip. Okay, so sticky note there, and let's just make sure our sticky note is serializable, and it is. Okay, that's fine. So we could do sticky note data, or say var notes equals notes data equals new sticky notes data notes data dot sticky notes equals. Can I do that as there? I think I can do equals new new iSticky note notes dot. I can't do get count, can I? From there. That's the one downside to using enumerable, is that you can't do that. Okay, but what we can do is var list equals new list sticky note list dot add range notes notes data dot sticky notes equals list dot to array, and there we have our handy dandy converted class. So this is our object that we're going to serialize, and then our serialization is going to be JSON equals JSON utility dot to JSON notes data, and then we're going to do let's do print JSON just now. Okay, so we'll do our save JSON just now. Okay, and then inside our controller, when we add a note, we need to get our serialization first of all. Okay, so let's get the serializer first of all. So I'm going to say sticky note serializer. So that's going to be the serializer there, and then inside our awake, I'm going to say equals get by I've got to do game object dot get by interface sticky note serializer. So I can't use the mono behavior one, so I can't use get component here, although get component is just a map to the game object's get component, but whatever. So there's our serializer there, and then up here in the add button I can say serializer dot save, and then we pass in the sticky notes, which is going to be notes dot values, and that should be all that we need to do there. So I'm trying to make this as Unity as possible. Although I have introduced the sort of interfaces here, which is kind of alien to Unity. It's certainly not alien to the C# programming language, that's for sure. Okay, let's go back to our serializer. So that's our save, and then we print out the JSON. So we still haven't decided where we're going to save it to, but this is us creating our JSON object. So now in our sticky notes UI, we can go to, it would be sticky note local disk serializer. Okay, so that's going to be our serializer that we then write out our data to local disk. All right, so let's create an object. Let's get the console open. So I'm going to create an object, add a note, and you'll see that we have an empty string there. So hello world. Save. So first thing is it's an empty object, which is not what I was expecting. That does seem a bit strange. There's no other errors there, but the one thing I did notice was that it should actually happen on the save. So instead of serialize save there, I'm going to change that to the save button, which is here. So let's just do some debugging here. I'm going to attach to Unity. So when we click on the save button, we'll end up back in this code here. Hope everyone's following along. I mean, maybe I could have split this video into 2 parts, but I said I was going to do a 3-part video and I didn't want to make it 4 parts. So, okay, so add our text there. So, humbug, get it? Humbug? Can't get my puns right. And then click on save, and then we get down to here. So we have our notes. So we have a count of 1. Although I don't know why we're in hexadecimal view there, but we're a count of 1. So then we want to do our add range, and our notes data is sticky notes null, and then we set the sticky notes to be 1. So we have one sticky note there. And then we pass in our sticky note and we press F10, and then JSON becomes an empty string. So I'm guessing it doesn't like it doesn't like non-solid classes. So what I'm going to have to do is I'm going to have to convert this to a serializable version of iStickyNote, which is a bit of a pain. So I'm going to do add class, and then this is going to be more behavior here, and then this is going to be sticky note data. I'm just going to call it sticky note data because I called the other one data, and this seems kind of appropriate. So sticky note data, serializable, and let's do using can't type, and it's be iStickyNote. So it's going to be iStickyNote. I'm going to implement the interface here. Whoa, that was more than I thought it was going to do. I don't want all that. So what I'm going to do is, instead I'm going to go into here, so I'm going to press F12, and then I'm going to copy all of this, and then go back here, paste that in there, and then I'm going to do my little trick where I can do private, oops, public even. There you go. So that's all I wanted to do, is have this sticky note here. And what I want to do now is I want to convert from whatever this is here, so whatever this is coming in as here, to this sticky note data. So sticky note data. Did I call that the same thing? Oh, what an idiot. Okay, I called that, okay, let's go through some refactoring here. Let's call this note collection, JSON note collection. So we'll call that JSON note collection there. And that means that that is there. Let me just bring this down here so we're kind of using it at the same space. And then I want this to be JSON sticky note, because I don't want to use this class for anything else other than just to write out to the data. This is kind of the downside of using interfaces with Unity, because if you use the JSON utility, it might not write out for you. And I was hoping it worked, but like I said earlier, I wasn't entirely convinced it was going to work. So now I need to do notes dot. This is where my link comes in handy, using system.link. So now I can say notes dot select, and then note goes to new JSON sticky note, and that's going to be bug text equals n dot bug text. Oh, again, position equals n dot position, scene equals n dot scene, and finally timestamp equals n dot timestamp. Okay, now you could probably get away with, not having this as an interface, or just casting this back to being a sticky note, but to be honest, I don't know. It's kind of messy, the conversion back and forth. This way is you're always heading towards something else. So I kind of prefer it that way, but it's up to you whether you want to do that or not. So that's going to select everything inside there, and then that's going to be list.add range, all of that. So hopefully that makes sense. I know there's a bit of link in there. It finally stopped ringing. There's a bit of link in there, but basically what we're doing is we're saying take all the items that are iSticky note and make this JSON sticky note object out of them. Make a concrete implementation of it out of them, and then add that as a range to the list. And then down here we have our JSON note collection, and then we set that to be to array, and then we print that out. So now, fingers crossed, now that we have a concrete class, let's just make sure everything's serializable. Oh, maybe it was because it wasn't serializable. Oh, please tell me no. Okay, I did mark that as serializable. And then this needs to change as well. So this needs to be a JSON sticky note as well. Sticky note there, and then that's got to be serializable as well. Okay, so it was serializable. Yeah, it's just interfacey things that Unity balks at occasionally. Okay, so create one, add a new note, test, and then click on save. And there we go. We have sticky notes, and then we have nothing there. So at least we're getting a little bit further. I don't know why that's not serializing. Public sticky notes. Okay, let me take this off, this sticky note off, and then let's make all of these. In fact, let's call that timestamp, position, bug text, and scene. Let's make them all like JSON names. In fact, that would be string as well. Let's make that a string. So now we have our bug text, position, scene, time, stamp equals that dot to string. Oops. Why is that not working there? Time. Oh yeah, timestamp. There we go. Okay. So yeah, so that's the interface is gone there. It's just pure data that we're dealing with. And text, test, click on save, and now we have the information there. So yeah, interfaces are a bad thing when you're using JSON with Unity. But we see we have everything in here. So we have our X, our Y, our Z. We have the timestamp. All that information is now stored inside there. Now, okay. So now what we need to do is we need to write that out to disk. Where's the best place to write that out to? Well, probably the asset folder. But let's go one, this is the asset folder here. So if I do show an explorer. So this is the asset folder here. So everything inside the asset folder is up for grabs, but maybe we want to store it at this level, so it's not in the asset folder. So let's do a void awake string path to file to file equals path dot combine application dot asset data path comma, and then it's going to be one back from that plus direct environment dot direct folder. Let's just do it this way. And then let's call it sticky notes.json. So I'll call it sticky notes.json. Okay. And then inside here we just do file.write all text, path to file JSON. So I'm going to keep this folder open here, so when we write out to that file, it should write out a nice JSON file to disk. Okay. And there, add that, test, and click on save, and go to here, and you see that we now have a sticky notes.json file. And if I click on open with, yeah, that's good enough. Sure. And you'll see that we have our sticky notes there. So let's go ahead and create another couple of sticky notes. So I'll go and create one over this side here, and I'll add a note, and this will be another test note, and click on save. And so now we have our two notes here. So if I flip round to this direction here, you'll see that we have our other note over there. And what we're going to do is we're going to write our deserializer now. Okay. So let me just close that here. And go back to the code. All right, so inside the code here, our load is going to be var JSON equals file.exists path to file, and then it's going to be if that's true, so if the file exists, I'm going to say JSON utility dot from JSON, and then this is going to be JSON note collection. Otherwise, it's going to be null. I need to explicitly call it that, or else it'll balk. Oh no, that's why. We need to do. Oh yeah, that's why we need to do that. Running ahead of myself. Okay, let's keep that for just a sec. What we want to do is we want to load that data. So we want to say file.read all text path to file. Then we want to say if string dot is null or empty, JSON return new sticky note. So in other words, just return a completely blank sticky note. We're not interested in it. We don't care. Haven't a clue. I don't know what's happening. Let's just forget about it. And then the next thing we want to do is we want to read in all those values and then create our enumerable there. So I'm going to create a list and we're going to call that notes, new notes, and then I'm going to say for each JSON var note in done it again. Okay, this is only us. Right. Okay. Right. What we're doing here. Let me start this again. What this bit here is determining if the file exists, and if it does exist, we read in all the text. Otherwise, we put in null. That's what this line does. So JSON at this point will contain, or this line here will contain either valid text, in other words, a JSON object, or it will contain null. So then we check to see if it's null. And if it is null, we want to early out, we want to return and just say, here is a blank collection. And what that means is that when the caller gets this, it won't balk at it, okay? It won't blow up. Now, the next part is we want to deserialize that JSON object. So I want to say var, what do we call it? JSON node collection equals JSON utility dot from JSON node node collection JSON. That should be note collection. Okay. Now what I want to do is at the very last line would be return notes, and that will satisfy that. Okay. But what I need to do now is I need to get those values in there. So I'm going to say for each var note in JSON note collection dot sticky notes, and now I need to do the opposite conversion. I need to get a sticky note out of there and then take that back. So what I'm going to do is I'm going to do exactly the same thing as I did down here, but I'm going to do it up here. So I'm going to do list dot notes dot add range. Actually, I can do that all in a one here, can't I? And then that's going to be JSON notes collection dot sticky notes dot select, and then it's going to be n to new sticky note. I think I'm missing. I'm missing another bracket. Add range, note select, bracket. Cannot collect from connections, numerable sticky note to I sticky note. Okay. Damn it. Yeah. It's not wrong, but it's a bit of a pain. Okay, let's do the old-fashioned way. For each var note in JSON note collection dot sticky notes. Var sticky, let's call it sticky, equals new sticky note. And then we want to say bug text equals note dot bug text. Position equals note dot position. Scene equals note dot scene. And then finally timestamp equals new date time note dot timestamp. I think that will work. Oh, actually no, I think you need to do convert dot to date time notes.timestamp, and then that'll work. Notes.add sticky. Okay, so that adds the sticky notes to, so that goes through all the sticky notes in the saved, the serialized JSON data. It then takes the values out of there and then takes all these values here, this right hand side, and then creates a sticky note and populates the left hand side, which is our sticky note, and then it adds those values back and then it passes it back to the caller. Now the caller is going to be our, where's our controller? Our controller is going to be the caller. So we have this add button thing here. So I'm just going to copy these values surreptitiously. I'm going to copy these values, not values, this code, and then inside the awake, I'm going to do load existing notes. Void load existing notes. And I'm going to say var existing notes equals serializer dot load. For each var note in existing notes. And what I'm going to do is I want to go through and create an instance of an object, and I want to specify node.position for that object. I want to get a copy of the note, and then I don't want to create a new note, but I do want to set it to be that value. So I want to say that equals, and then it's going to be note, and then what else do I want to do? I then want to set the text of that node. So I want to say current note dot set note, and that's it. So I don't need any of that code there, and that will load everything in there. So that's going to reload everything in. So we're going to load all the values from the file, and again, this code does not need to know anything about where that information comes from. We just call load. So when we get to the next video and we do the database loading, then we don't care. None of this code changes. None of it. We don't change anything. The only thing we're going to change is we're going to swap out our local serializer with our database serializer, but this code in here doesn't change. We never need to change this code again because it just loads it from someplace else. So it loads in all the existing data, all the existing notes, and then we go through each one of the notes. We create a bug report prefab at that particular position, and we specify the current note is going to be that. Actually, do we need the current note? Yeah, we kind of do. But we really don't want to know the current note after that. Do we? Yeah, let's make that null, because that might be an issue if we're, yeah, let's set that to null. And then, because if we don't set that to null and we're in the middle of the world, that will be the last note that we see. So that's probably a bad idea. Actually, let's make that, let's not change current note at all. Let's just have var cn and change those values to there. So it's current note, but it's not current note. And then, yeah, then we set the value there, and then when we run it, drum roll please, we should get our existing data. Ta-da! Test, 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 and then over here, once it swivels around, we have another test. Let it swivel around. Then we have our other test there. And we can go ahead, we can go and create more bugs as well. So if we go over to here, is there a run fast button? No. So we can go over here and create another note. And then this is from another session. Then click on save. And then when we come back out, so everything's saved. So when we come back into the game, we get test, 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 and then we go down here, we got another session. So that's your notes. And the nice thing is, if you decided that you didn't want to, let's say you don't want to run any of this, just turn off your sticky note UI, and then when you run the game, the notes are gone. The notes just don't load. And similarly, if you if you don't want to ship this code, you just delete that one object that I just turned off there, and none of the code gets included. So yeah, it's a kind of win-win situation. So that's kind of where we are with the serialization part of this. I think we're done. I think we've done everything we needed to do. Making the system extensible. So we've kind of done that for. Let me go full screen here. Okay, so that's the end of the video. It's another hour and a half long video. So what have we done? I'm going to look over here, so I'm not looking at the camera, so I do apologize. Actually, I can move that a little bit over to here. So the goal of today was to get serialization to work. So I think we've done that. I think we've achieved what we set out to achieve, which was to read and write data from the disk. And we're just going to put it in a big file. You could filter by the scene name, all that kind of stuff. I think we'll probably put that in the next video. There's a lot of things that you can actually add to the functionality of this. You could have a report about, where most of your bugs are. So you could have a list of all the bugs per scene. So it could be that, there's a level at the start that's got a load of bugs. There's a level at the end that's got a few bugs. You might want to do the bugs at the level closest to the beginning, because that's the one that the most players will see. That kind of thing. So you could do a report on that. So yeah, we did the serialization there. So when was the best time to save? Really, when you hit the save button. Ironically, you save there. Notice that as well that when I was writing the code, I explicitly made sure that we're not going in circles. Everything goes in one direction. So when we load the database, we load everything into memory, and then we use the memory from that point to then write out to the disk. So the load only ever happens once. It only ever happens at the start to initialize the database, the internal in-memory database. And then after that, the internal memory database writes out the information, we use the information from the internal database to write that out to the disk. We also did the some component work as well. So we abstracted the interface for the note object, which you could probably didn't need to do, but we ended up doing it anyway, and it caused a little bit of problems for serialization. So there was a kind of bit in the middle there, but we got through it without too many pauses and ums and ers. We did do the interface for serialization, and also the interface for the prefab used to display bugs in the world, and you saw that you can have whatever one you want. As long as you implement that interface, the system will work just as well at any other time. So that's a good thing. Then what do we have? I think that's us. Yeah. So the only thing left now is moving the data to a data service. So I'm going to try and figure out what a good data service is. It'll maybe be Amazon or Google Cloud or something. I don't know. Actually, what we could do is we could use the Google spreadsheets that we did from earlier on. We could put that information up there, and then that would save it to the cloud. So that, yeah, there you go. That's what we might do. I haven't decided, but the genius of all of this, though, is that you're only ever coding to the interface. So it doesn't matter whether we decide you're going to do it on Google Sheets or you're going to do it on Amazon Web Services. The only thing you have to swap out is that one component, and then you've got everything for free. So I think we're gonna call it a day there. Thank you again so much for watching. I really appreciate this. If you like this video, please feel free to share it on social media. That really it would help the channel out a lot. If you liked the video, please thumbs up. If you didn't like the video, thumbs down. Either way, let me know what you liked, didn't like about the video. If you haven't subscribed already and you have got it an hour and a half or so into this video, then you might as well subscribe at this point. It's a lost leader at this. You know, you need to think about how much, you know, the sunk cost fallacy and all that kind of stuff. So subscribe. Why not? It's free. I don't charge for it. It is a bit of a pain. You got to click on subscribe, and then you got to click the bell icon, then you got to check box, then click on allow or OK or whatever. Google. Yeah, thank you for watching, and thank you for getting through another hour and a half long video. Very much appreciated. Thanks again. Bye bye.